Good morning. Pleasure being here again with you, and of course with you, the audience. So I have two topics today, and the first one doesn't switch forward. Can you give me the other one? The first one is a roller mill. So I remember the good old times of my Feedmill when we were only allowed to use 3 slides. So in the meantime, this has been expanded a little bit, so we are allowed to use more than 3 slides. But I try to keep it to the core information, because basically I think you all know a Feedmill. So, but let's see what can a hammer mill and a roller mill doing. So hammer mill we learned already from Van Asen. Now I give you some information why there is a roller mill. So, and this comes to the energy efficient grinding, and this comes of course to the coarse particles. So, and coarse particles, I think my technology in my hand is randomly working here. You have another one? Otherwise, you give me the next slide. Oh, maybe. Oh. So, no, it's lost. So what is a roller mill doing? It gives you a minimized fine content, and it gives you a very nice and narrow particle size spectrum between the max and the minimum particle size you want to have. And that's the difference compared to a hammer mill. So here you can see the yellow arrow going down to the 0.5 millimeter screen size here. Yeah. So, and you see the red line, which is a hammer mill, makes already roughly 30% smaller 0.5. Whereas the roller mills here on corn and wheat just make roughly 5%. So, and that's a big difference compared to hammer mill grinding. And of course, when you want to produce a layer feed which goes now in the ground capped chicken houses there, that makes a big difference for the feeding results. And the same when you go for the broilers, and also when you go for pig feeds, where you like to have the coarse particle size spectrums. So, and then you can see the curve going up here, and then we end at 2.8 millimeters, and we have a very nice particle size yield between the 0.5 and the 2.8 millimeter with a roller mill compared to a hammer mill. So of course, there are always ways to improve this by all technologies, but compared, when it comes to the particle size spectrum, the narrow particle size spectrum, the roller mill has a very strong impact on that. So now going into the layer feed and broiler feed. The broiler feed is a little bit finer compared to the layer feed, and here this is based on a mono material or a mixed feed. We want to have 95% smaller 3 to 4 millimeter, and we have 70% between 1 and 4 millimeter with a roller mill. So that's a very good result. And now when we talk about a capacity, a typical roller mill by Kahl makes up to 50 tons on this result here. Going now into a pig feed. For pig feed we like to have a little bit smaller, 90% smaller, 1 to 2 millimeter, and we have here 70% between 0.5 and 2 millimeters. So we have a little bit over 2 millimeter and a little bit less than 0.5 millimeters. So, and here the typical capacity is 35 to 40 tons. Oh, that was too fast. Coming now to energy. So a roller mill has very low energy input. So not even 2 kilowatt hours per ton. So, and now I assume a hammer mill has roughly 7 kilowatt hours per ton. So we save 5 kilowatt hours per ton. And if we now have 30 tons per hour, 6,000 hours and 12 euro cents per kilowatt hour energy cost, this is a saving of 108,000 more than 100,000 euros a year on electricity. So, and the other way, you can, of course, also have a combination with a hammer mill, so that only the materials which are difficult to grind with a roller mill will go onto the hammer mill. So then we have a combination of 7 for the hammer mill and 2 for the roller mill. So, and then we come up with an energy saving of 2.9 kilowatt hours per ton, and then we still have a saving of roughly 60,000 euro per year. So, and these are the figures. There are also other advantages when you have a roller mill. You can install a roller mill basically into any existing feed mill. You don't need an exhaust, which goes outside, so you don't need filter systems. It's easy to put in without any further regulation and authorities being involved, and that makes it easy for installation of a roller mill into an existing installation as well. So there are also plenty of opportunities how to arrange a roller mill together with a hammer mill. Do it parallel, do it before, do it after, with screening in between, so to make use of the efficiency of a roller mill for the particle sizes you want to produce. Okay, that is number 1. And can you switch to the next one, please? So for number 2, I will take maybe 1 minute more. Coming now to the expander technology, which was introduced by Amandus Kahl more than 30 years ago to the feed mill industry. And I will focus today better pellet quality, better pellet mill capacity, and of course efficient salmonella elimination or bacteria elimination, so hygiene aspect and the superior feed quality. This is a screenshot here from a Vietnam line working on the expander from Kahl, working on a 900 millimeter ring die pellet mill, 26 tons per hour capacity. So we have in the meantime more than 25 expanders running in Vietnam. Roger said it nicely, it's a very dynamic market, Vietnam. And our numbers for expanders are growing well with the big players in Vietnam. But even more dynamic is Brazil today. So without a Kahl expander on top of a pellet mill, it's difficult to sell a pellet mill today. So, and a typical capacity on a 1200 millimeter ring die today in Brazil is 60 tons. And we have already 50 expanders in Brazil. So 60 by 50 by 6,000 gives you a roughly number what amount of feed is produced in Brazil with expanders, and that has reasons that the people take so many expanders on pellet mills today. I'll give you now a brief introduction on the thermodynamics and energy consumptions. We start with the raw material with 10 to 12% moisture content and a temperature of 25 to 30 degrees now. So when Mr. Brownback is here, maybe it's 5 degrees less from the grain cooler. So, and then we go here into the conditioner. Could be a normal conditioner, single conditioner, just adding some steam to get a temperature of 65 to 85 degrees centigrade, and we have a moisture content between 13 and 17% depending on the feed. So we add 3 to 5% steam. That's what you know from the normal pelleting process. It remains the same basically. And we have the option to add 1% of water, because an expander processed feed is non-sensitive to moisture. So we go into the expander with 13 to 17%, and then we put mechanical energy in and reach outlet temperature of 75 to 120 degrees. So this depends a little bit on the animal, what you do. The pig feed starts at 75. When we go for broiler feeds, we are maybe at 105, 110, and when we go to pig feed with a higher starch gelatinization, then we go to 120 degrees. Energy inputs for the 120, you go to 15 kilowatts. On the lower side, the 75, then you may only add 8. Typically broiler feed 10 to 12. Now I go next immediately to the pellet mill, energy input. The pellet mill is not compressing anymore, it's only shaping. So you can reduce the effective press wavelength by 40%. And the stress on the pellet mill is much lower, only 4 to 6 kilowatt hours per ton typically are used in the pellet mill. And you make here very high PDI values with this combination. So the pellet mill is just shaping the material with very low energy inputs, because all the work has been done by the expander already. And what we see after the expander is a flash-off effect. So we lose about 2% of moisture at the outlet. So that's why we can add also 1% here. The pellet mill will not slip because it doesn't need to compress, it's only shaping. The material is very easy. So starch gelatinization has happened, so very easy to shape a very good pellet. And then we go to the cooler, as usual, cool down, moisture, thermodynamics. During the cooling ensures that the moisture goes to the levels desired. So that's the thermodynamic of a line. Now, impact on pellet mill capacity, pellet quality, easily 98 or higher pellet quality. Typically, now take a broiler feed line, 20 to 30 is conservative, is the increase of the pellet mill capacity. So very good for existing plants if you want to go back to plant nominal capacity. Of course, now your pellet mill, your line is a little bit older. You don't get the full capacity anymore because the customers want a very good pellet quality. With the installation of an expander, you go back to full capacity of the plant. And for new plants, as mentioned in Brazil, people want to use expanded feed. And now going for duck feed, for example, with duck feed even you double the capacity of the pellet mill. So we saw many plants here in Southeast Asia increase from 5 to 6 to 10 to 12 tons capacity on the duck feed. And now also very important, formula saving. Animal nutrition, many times we hear it, and this is now something here from the Feed magazine. The expander increases the digestibility of the feed by 50 to 70 kilogram per kilogram. So now we can make use of this. Many times it's not really desired that the broilers shall have more energy in the feed because the genetics will not allow to grow them better anymore. Then what we can reduce? We can reduce in the recipe the calorific value by 50 to 70. And how can we do that? For example, we take out high energy vegetable oil, which has a high price, and replace this by corn, which has a lower price. And in the end, the metabolizable energy in the feed is the same. But for the company, this is 6 to 10 US$ saving per ton of mixed feed. And that's a substantial saving what, for example, an integrator can achieve by using expander technology on the pellet mill. Hygiene effect. So now hygiene, we can visualize hygiene. We see here Escherichia coli bacteria before expander. And we can see here the same after being eliminated during expander treatment. So the feed is intrinsically clean. It's fully hygienized. What we see in the markets, in Brazil, in Southeast Asia, the feed millers save roughly $2 per ton on the acidifier or on the probiotics added to the feed because the feed is clean. Okay. Thank you very much for your attention. Any questions? Hall 6, booth 2724, please. Thank you.